To solve a polynomial using the zero product property, you may need to factor the polynomial. Factor using the greatest common factors of the polynomial's terms. So as I mentioned in a previous video, in order to solve these polynomial equations that have an exponent greater than 1, what we need to use is the zero product property. And if we're going to use the zero product property, two things need to happen, two very important things, and that is number one side has to be set equal to 0, and number two, the other side has to be written in factored form. So what you're going to run into is you're going to run into problems where you do not have the one side written in factored form. And if we're going to be able to solve those equations, and if we're going to be able to use our zero product property, we need to review how you factor polynomials. So first, this right here, this is in factored form. So if you wanted to apply the zero product property with this expression right here, you are ready to go. And the other way that I could view this as an expression is just distribute the 7 and get 21x plus 35, and that is not factored. So if my equation looked like this, if I had 21x plus 35 equals 0, I would not be ready to use the zero product property. And to be quite honest, I don't even need to use the zero product property here. This is linear, and I can just solve that equation using my order of operations in reverse. But the minute that my polynomial here does have that exponent greater than 1, I'm not going to be able to do that. All right, so let's go in reverse order. So this time I'm going to give you the unfactored form, the 8y squared minus 24y, and we're going to work together to come up with the factored form. So whenever you factor this, the very first thing with factoring polynomials is that you always want to look for the greatest common factor. So what is my greatest common factor between 8y squared and 24y? And let's show that using our process that you learned back in the pre-algebra days. So if I have 8y squared and I want to write that in factored form, I can write 8 as 4 times 2, and the 4 would be 2 times 2. So in factored form, this is 2 times 2 times 2, or 2 cubed, times y for the y squared, or y squared. And I'm going to write this out the long way just to avoid any confusion. The 24y, so let's write that in factored form. So 24 would be 3 times 8. So I definitely have 3 as a factor. And the 8, I just worked that up here, was 2 times 2 times 2. So 24 should be 2 times 2 times 2 times 3. And if you multiply these factors out, you will get 24. 2 times 2 is 4, 4 times 2 is 8, 8 times 3 is 24, and then I still have that y in there. And when I'm looking for greatest common factor, I'm looking for all my factors that are the same in both of these lists with my algebraic factorization here. So I have a pair of 2's in common, I have a second pair of 2's in common, I have a third pair of 2's in common, and I have this pair of y's in common. So multiply this out, 2 times 2 times 2 times y, and you will have your greatest common factor. So that would be 8y. 2 times 2 times 2 times y would be 8y. Let's write that in both of these. So this 2 times 2 times 2 times y can be written as 8y. And if you look over your leftover factors, you'll see what you have left here. So 8y squared can be thought of as 8y times y, and 24y can be thought of as 8y times 3. This right here, this 8y, is my greatest common factor. And when I factor this polynomial, I need that greatest common factor in this spot right here. So I'm going to rewrite 8y squared minus 24y with 8y out here. But I still need to figure out what's in here. Well, looking at this, I already know. I know that 8y squared is 8y times y. So if I was distributing this 8y, I want to be thinking to myself, 8y times what would give me 8y squared? Or the other way to look at it is if I have an 8y here and I factored that out, I'm really dividing each of these terms by 8y. So I can think of it as, what is 8y squared divided by 8y? And in all of those cases, the answer is y. So in this part of my expression, I'm going to put a y. And with my other part here, I have this 24y. So if I'm factoring out or pulling out an 8y, I'm dividing this by 8y. 24y divided by 8y would be 3. And we want to make sure we get the right sign in here. This is minus 24y. This is going to be minus 3. And notice that always do a quick check after you factor, because people tend to be a lot more comfortable with the distributive property than they do with factoring. So that's a way to always catch your mistakes. So if I do 8y times y, that's 8y squared. That matches up there. And 8y times negative 3 would be negative 24y. This is now written in factored form. And when you're doing a problem like this, you might not even need to do this right here. But if you're ever stuck, you know, if you have this polynomial and you have no idea what your greatest common factor is, it'll take you a little bit of time. But if you write out the algebraic factorization of each of those terms and figure out the stuff in common and multiply that stuff together, you'll have your GCF. So there's a good systematic process for you to follow. Now I want to do one more example here. I'm going to do this 48a to the third minus 54a squared plus 6a, just to show you one that has 3 terms. And one thing I want to point out before I even start this problem is that we are not going to factor this completely. Okay, so for factored, I'm going to draw a line right here. Because what I get over here is not going to be factored completely, but I just want to deal with that first step of factoring. That's really my focus on this slide. And that first step in factoring is just to be able to pull out your greatest common factor. So can we find the greatest common factor here between 48a to the third, 54a squared, and 6a? And I'm going to show this to you in another way. You might remember back from your pre-algebra days, we used to have little rectangular models here. And what I'm going to do is I'm going to take my polynomial and just fill in the parts here. So 48a to the third, I'm going to write as the area of this rectangle right here. And this minus 54a squared, I'm going to write as the area of this rectangle right here. And my last rectangle is going to be this 6a. And nothing here is drawn to scale. Now, when I write this in factored form, I'm going to figure out what my GCF is, and I'm going to put that in this spot right here. So what is my GCF between 48a to the third, 54a squared, and 6a? And unlike the last example where I did it the long way with writing out the algebraic factorization of both of those terms, I'm just going to kind of think this through. So if I'm looking at these numbers, 48, 54, and 6, let's just go through and think of numbers that would evenly divide all 3 of these numbers. The largest number that evenly divides 48, 54, and 6, that number is going to go right here. So with the smallest number, you know, with this 6, I know I can't have any number bigger than 6. So, you know, even though 54 has a factor of 9, for example, I'm not going to be able to pull out a 9 because that's not going to evenly divide this 6 right here. So my largest factor with 6 would be 6. Does 6 evenly divide 48? And can I do 54 divided by 6? And the answer is yes. My GCF, in terms of the number part here, is just going to be 6. With the variables, and the big secret with the variables is that you always just want to take your smallest power or your smallest exponent. So if I have a cubed, a squared, and an a, and I'm pulling stuff out of here, I cannot pull out more than my smallest, which is just a to the first. So I can pull out an a from all 3 of these terms. I can pull out an a squared from this term, I can pull out an a squared from this term, but I cannot pull out an a squared from here, so my variable is just going to be an a and nothing bigger. So that's my GCF, 6a. So now I need to think, 6a times what would give me 48a to the third? Well, it's 6 times 8, that would give me the 48. That takes care of the number part. And it's a times a squared that would give me the a to the third. So 6a times 8a squared gives me 48a to the third. Now let's deal with this one. 6a times what gives me negative 54? That would be negative 9. A times what gives me a squared? That would be a. So 6a times negative 9a gives me 54a squared. And with the last piece here, 6a times what gives me 6a? That has to be a 1. So in partially factored form, this 48a cubed minus 54a squared plus 6a can be written as 6a times the quantity 48a. Oh, I'm writing the wrong part there. Let me go back. When you write this in factored form, you want to take this piece times this piece. So 6a times 8a squared minus 9a plus 1. All right, so I have now factored out my greatest common factor. One more thing to note here is that, like I was saying, this expression is actually not completely factored. The 8a squared minus 9a plus 1, this right here can be factored, and that's something that we're going to have to be able to deal with in the future. But as for now, I really just want you to be okay with pulling out your greatest common factor and writing it in factored form with that greatest common factor out here on the outside.